Hello everyone, welcome back to my channel. Today we are starting with one of the most fundamental chapter in physics, that is units and measurement. This topic is the foundation for all the further studies in science and engineering. Whether you are preparing for the MSBT diploma, integrate Btech or any technical course, this is a very fundamental chapter because every scientific calculations, every experiments and every engineering designs, it begins with the accurate measurement and correct units. Without a strong base in this chapter, it's very difficult to understand the advanced topic like mechanics, thermodynamics, or electronics. So it is very important to learn the base chapter, that is units and measurements. So guys, in this chapter we're going to cover what is the unit, what are the physical quantities, then system of units, what are the scalar and vector quantities, dimensional formulas and its applications. Then we're going to go learn for the errors and types of errors. And lastly, we're going to learn applications of vernier caliper and screw gauge in details. And we're going to solve some numerical based on this syllabus. So we start units and measurement. First, I will going to explain what is the measurements. Measurement, it's a comparison of unknown quantity with the known quantity. It's a comparison of unknown quantity with standard quantity. For example, if you want to know the length of your pencil, you keep it to the next to the ruler. The ruler has marking in centimeters or inches. So by comparing, you can say that the pencil is 15 centimeter long or 12 centimeter long. Now what you are doing here? You are just comparing the unknown length of the pencil with known scale. So actually we are just comparing here unknown quantity with the known quantity. Known means what? It's a standard quantity. So measurement helps us to know how much of the physical quantity is present. Now one more important thing is that every measurement has two essential parts. Numerical values, that is the magnitude. It tells us about how many times the standard unit is present. And unit, this tells us what standard we are using. Now for example, here 15 centimeter. 15 centimeter, 15 it's a magnitude, it's a number, and centimeter it's a unit. Apple is 200 grams. 200 it's a magnitude and gram it's a unit. So measurement means what? It's a comparison of unknown quantity with known quantity. Now we can easily understand the units. Unit of a physical quantities. Now what is the physical quantities? Any quantity which can be measurable in numbers. That quantity is known as the physical quantities. Now what is the unit of physical quantities? The standard used to express the measurement of a physical quantity, it's called as the unit of that quantity. For example, here a student walks 2 kilometers. 2 it's a magnitude, kilometer it's a unit. A person weighs 72 kg. Kg it's a unit. A table is 2 meter long. Meter it's a unit. The area of house is 200 meter square. Meter square again it's a unit. That means what the standard we use to express the measurement of a physical quantity. That is known as the unit of that physical quantities. Now just take the daily examples. Buying fruits in mass, we use the kg. Timing a race in second. Electricity bill in kilowatt. Pressure we measure in Pascal. So these are all the kg, second, Pascal, meter square. These are all the units that we use. So what is the unit of a physical quantity? The standard used to measure the physical quantity, it's known as the unit of that quantity. Now guys, there are some requirements for the standard units. Now guys, why do we need standard units? Now just imagine that one person measures length using his hand span, another person uses a footstep, and third person he uses a stick. Will they all get the same results? Absolutely no, because everyone's hand, foot or stick is different. So that's why scientists they decided we must have a globally fixed standard units. It will be same for everyone everywhere in the world. So there are some requirements of the standard units. First, it should be well defined. That means what? A unit must be precisely defined so that there is no confusion between the people or there is no ambiguity. For example, the meter was earlier defined as the distance between two marks on a platinum iridium rod. But that bar could be expand or contract due to the temperature. Now it is defined more precisely as the distance traveled by the light in vacuum. So what is the advantages of this? Anyone can understand and anyone can use definition without any doubt. Second, it should be easily reproducible. That means what? The standard should be such that it can be produced or verified in any laboratory or country. If a unit depends on a unique object which kept in a one place, it's not a practical. Third, it should be universally accepted so that people from the different countries can understand and exchange the data without any confusions. Now, fourth, it should be invariable. That means what? It should be constant with time and place. A good standard must not change with time, place, or any environmental condition. For example, a metal rod changes the length with temperature, so it's not a reliable. The speed of light, however, is a universal constant that never changes, so it is the excellent base for the defining the units. So a unit should be invariable, constant with time and place. Fifth, it should be convenient in size. That means what? The chosen unit should be of a practical size. It should be neither too large or too small for the daily use. For example, the meter is a convenient for the everyday distances. For very small distances, we can use the nanometer for the wavelength of light. That means what? The unit should be convenient in size. And last, it's easily accessible. That means what? The unit should be based on something that can be easily accessed by the scientists anywhere, people by the country anywhere. So to be a good standard, a unit must be well defined, easily reproducible, universally be accepted, constant and invariable, constant in size, and it can easily accessible. So these are all the requirements of standard units. Now types of physical quantities and their units. Actually, physical quantity is broadly divided into two groups, fundamental quantities and derived quantities. Fundamental means what? It's a base quantity. The quantity which do not depend on any other quantity for its measurement, that is called the fundamental quantity. Actually, there are seven fundamental quantities: length, mass, time, electric current, absolute temperature, luminous intensity, and amount of substance. Actually, we measure the length in meter, mass we measure in kilogram, time we measure in second, current in ampere, temperature Kelvin, luminous intensity we measure in candela, and amount of substance we measure in mole. So these are the symbol for the seven fundamental quantities. So these are the seven fundamental quantities and these are the seven fundamental units. Guys, there are two supplementary quantities also there. Plane angle we measure in radian and solid angle we measure in steradian. So these are all the fundamental quantities which are the base quantity which does not depend on any of the other quantity for its measurement. So we call it a fundamental quantity. Now second, it's a derived quantity. Derived quantity means what? It can depend on any other quantity for its measurement. Actually it depends on the fundamental quantity for their measurements. The physical quantities that depends on the fundamental quantities for their measurements are known as the derived quantities. And the unit of derived quantities, it's known as the derived units. For example, area, velocity, energy, work, power. These are all the derived quantities because they depends on the fundamental quantities. They derived from the fundamental quantities. Now for example, here density. What is the density? It's the mass upon volume. Mass upon volume. Volume. How we calculate the volume? Length, width and height. So again length, we take it from the fundamental. Width, that means what? Length. Height, again length. So actually mass and length actually we have taken from the fundamental quantities. So we can say that mass upon volume, it's a derived quantities. And what is the unit of that? Kg per meter cube. It's a unit for the density. That means what, guys? Actually, derived quantity means what? Which can take the help of fundamental quantities for their measurements. So that is known as the derived quantity, and their units, it's known as the derived units. Try to understand the difference between the quantity and its unit. Take one more example of power. What is the power? Power, it's a work upon time. Yes, but what is the work? It's a force into displacement. Now again, what is the force? Force, it's nothing but it's a mass into acceleration. Again, just put into this equation. So mass into acceleration into displacement upon time. Again, what is the acceleration? It's a rate of change of velocity. That means what? Velocity upon time. So we can say that mass into velocity upon time into displacement upon time. Now this time will comes here in a denominator. So your equation will be mass into velocity upon time into displacement upon time. That means again here the velocity, it's nothing, it's a displacement upon time. So whole, you can just observe that this displacement, we use the length, again time, mass, these are all the fundamental quantities. So power is derived from the fundamental quantities. Power, it's a derived quantity. The quantity which can be derived from the fundamental quantity, it's known as the derived quantity, and their unit, it's known as the derived units. These are all the derived units. Acceleration, rate of change of velocity, we measure in meter per second. Force, mass into acceleration, kg into meter per second square, we can say it's a Newton. Energy, energy and work, force into length, area, meter square, volume, density, power, pressure, momentum, these are all the derived quantities. They are depends on the fundamental quantity for their measurements. Now, system of units. Here there are four system of units. CGS system. CGS stand for the centimeter, gram, second. Actually here we measure the length in centimeter, mass in gram, time we measure in second. Actually this system first introduced in France. It's also known as the Gaussian system of units. Actually we use this CGS system for the small measurements. FPS system, foot, pound, second system. Actually this system firstly used by the Britain. Actually they introduced this system. So we measure the length in feet, mass in pound, and time in second. It is also known as the British system of units. Third, it's a MK system. MK system stand for the meter, kilogram, second system. In this the length we measure in meter, mass we measure in kilogram, time we measure in second. This system was first introduced in France, so it's known as the French system of units. And then lastly, for the globally to get the common platform to work together, actually we developed the international system of unit, that is the SI system, in which there are 7 fundamental quantities, 2 supplementary quantities are there. So this is the SI system. Guys, if you find my videos helpful, please like, share and subscribe to the channel so that more students can benefit of it. Thank you for your support.